Okay. So when you apply a quadratic formula, suppose you have an equation which is um, x square plus 2x plus 5, okay, and that is equal to 0. Now you solve this equation by applying the quadratic formula. So what do you get? That is minus 2 plus minus square root of 4 minus 20. Okay, so that is over 2. I think it should both be like this, only then my writing can be sahi. Okay, so now this is going to be x equal to minus 2 plus minus, and that is square root of minus 16 over 2. Now when we reach at this level, we simply say that there are no real roots, okay? But now we have to go beyond that. Now, if the roots are not real, then we say that the roots are going to be the imaginary roots. Okay. Now, before I go further into writing these complex roots here, let's revise this quickly. Writing a surd into its simplest form. How many of you remember that if you have under root 8, so what can you write it as? So this can be written as 2 under root 2. Okay? If there is, let's say, under root 20, so what this can be written as 2 under root 5, because 20 is basically, let me just explain you, that is 5 times 4. So this is under root 5 times under root 4. So you can write it as 2 under root 5. Okay? Now, since we have to learn these complex roots here, so now if you have, let's say, under root minus 8, okay? So this can be written as under root minus 1 times under root 8. Okay? So this is, this under root 8 is going to be 2 under root 2. And now this under root minus 1 has a new name. We shall be writing I here, that is iota. Okay? This is 2 under root 2 iota. Okay? We have under root minus 16. So how can I write this in the simpler form? This will be 4 iota. Okay? Let's say you have under root minus 20, because I have just written this into the simplest form. So I'm just going to use this. So that will be 2 under root 5 iota. Okay? So now I'm coming back to this now. So this equation's roots are going to be minus 2 plus minus 4 iota. That is over 2. Okay. Now this is these are the complex roots of this equation, and you can write it as minus 2 plus 4 iota over 2, and then this is minus 2 minus 4 iota over 2. Acha. Now one thing that you have to remember, you have to keep in your mind for the rest of the chapter, that you have to split this number, because this number has two parts. Like if in general we have a complex number z, which is a plus iota b. Okay, so this a over here, this is the real part of this complex number. Okay, you can see that this minus 2 over here, or if I just split this is going to be minus 1 plus 2 iota. This is going to be minus 1 minus 2 iota. So 1 is the real part. So if I tell you exactly how to mention this, the real z, if this z is a complex number which is a plus iota b, then the real z would be a. Okay, so let me say that if you have a complex number which is let's say w, that is 5 minus 10 iota, or there is a complex number v, which is half plus 3 over 4 iota. There is a complex number w that is just 7 iota. Okay, so if I ask you that what is the real part of this w, so that will be 5. What is the real part? Like you will read it as real part of the complex number v. That is going to be half. The real part of the complex number w, that is going to be, what is the real part here? 0, because you don't see anything here. So that is going to be 0. Okay. Now, so that is why you have to split your complex number into two parts. You can't just write this something into the whole number, or something divided by the whole number, or something raised to power anything. So this has to be simplified until it just has two parts. One is a real part and the other is the imaginary part. Okay. Now, this iota b over here, now this belongs to the part where it is we have the imaginary number, because actually this under root of minus 16 does not exist. There is no such number. If you square that and you get minus 16. Okay, so that is why this is the imaginary part. So the imaginary part of this, will be writing this as im z. That is the imaginary part of this complex number z is b. You will not write iota with that. Okay, this is the imaginary part because it is a multiple of iota here. Okay, like here the imaginary part of this x is 2, and here the imaginary part of this x is minus 2. Okay, if I go to this one here, so what is the imaginary part of this w? Minus 10. Okay, what is the imaginary part of this v? That is 3 over 4, and the imaginary part of this w, that is 7. Okay, acha, now going back. Now these complex numbers, whenever they occur, whenever they exist, they always exist as a pair of numbers, because these have been derived, these have been obtained through the quadratic formula. Okay, so whenever you're told that fla equation has a root 3 minus 5 iota, then you must have in your mind, yes, this equation will have another root, which will be 3 plus 5 iota. But given that a certain equation has a root a plus iota b, then the same equation will definitely have a root which is a minus iota b. Okay, so the complex numbers always exist as a pair, and this is to be precise, this is called a conjugate pair. Okay, so if I ask you that what is the conjugate of minus 1 plus 2 iota, so that will be minus 1 minus 2 iota. Okay, Achha. Now I have to take you guys towards the 4 operations on these complex numbers. Before I do that, I want you to be familiar with this iota, okay, and the different powers on this iota. Now, whatever I will be writing over here, you have to answer you have to give your answer in terms of iota or 1, okay. Now, we know that this iota is basically square root of minus 1. So, so this is square root of minus 1. So this, I had to write a minus here. Now, you have to tell me what will be iota square. That will be minus 1. So this is minus 1. So this is the first time you're seeing that you're squaring something and you're writing that equal to minus something. This has never happened before in your life, provided that you haven't studied the complex numbers before. Okay, so we always know that, like, you know, if there is, for example, if x is equal to minus 2, then x square is going to be 4. Okay, so the square always gives us a positive number, but in this case of this iota square, that will be equal to minus 1. Now, what will be iota raised to power 4? That will be positive 1. Okay. Iota raised per 6. Okay. Okay, so iota raised per 4 is 1. And what is iota raised per 6? Why it is negative 1? Exactly. Because you know that this is going to be iota raised per 4 times iota squared. So iota raised per 4 is 1 and iota square is minus 1. So that is why this will be minus 1. What will be iota raised to power 8? Now this SAT people, they should see this clearly. Yeah, this is 1. Because this is iota raised per 4 times iota raised per 4, that is equal to 1. What is iota raised per 10? Minus 1. What is iota raised per 12? 1. Iota raised per 16? That is also. So is there anything developed in your mind that in what case this is 1 and in what? Yeah, so whenever this power on this iota, it is a multiple of 4, then this is going to result as 1. If it is even, but it is not a multiple of this 4, so then it is going to result as a minus 1. So then what is this iota raised for 50 going to be? That is going to be minus 1. And iota raised for 60? That is 1 because 60 is a multiple of 4. Iota raised for 100? That is 1. Iota raised for 50,006? Anuj, you're using calculator, beta. Don't use calculator, beta. Iota raised for 50,006. How do you determine that if an even number is divisible by 4 or not? No, 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 no. No, 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 no. You look at the last 2 digits, the combination of the last 2 digits. If it is all zeros or like it's making a number which is a multiple of 4, the whole number will be a multiple of 4. Like, you know, this 100 is a multiple of 4, but 50,006 is not a multiple of 4. It is just an even number, okay? So this is going to result as minus 1, okay? Look at this, 10,002. Is this 2 divisible by 4? No. So this is also going to be minus 1, okay? Got it? Okay, now, this was about the even powers, okay? Now let's talk about the odd powers. Now suppose if I have to answer this iota cube, or iota raised per 5, or iota raised per 7, or iota raised per 9, or iota raised per 11, or iota raised to power 13, or iota raised to power 17, or iota raised to power 51, or iota raised to power maybe 59. चलें इसको 61 ही रखते हैं. And iota raised per 101. Why am I writing these in front of all these? Because you can take this as a clue. So we know one thing, that if your power on iota is odd, it is going to result in terms of iota. Now we have to see that if it is going to be positive iota or the negative iota, okay? Now, so what is iota cube then? Negative iota, because iota cube is basically iota square times iota. So we know that iota square is minus 1. So this is going to be minus iota. Iota raised to 5 is basically, this is iota raised to power 4 times iota. So that is going to be iota. So you have to look at, for example, whenever you get let's say you have to find iota raised to power 21, suppose. So you have to see that what is that iota, what is that even power before that 21. So that is 20. Now, is that 20 a multiple of 4 or not? Okay, so like this is going to be iota raised per 20 times iota. So we know that this is a multiple of 4. So this is going to be just iota. Okay, now please write them. What is iota raised per 11? Is that plus iota? Yeah, minus iota. Okay, this is going to be just iota. This is iota. And this one is minus iota. This is iota, iota, minus iota, and minus iota. So this is how you play with the powers on this iota.